4.4, the law of conservation of energy. So the energy is not gonna destroy, it's just will transfer from one form to another form. So knowing that, see this ball is here, it has some potential because it has a distance between that and the ground. And as you give it the velocity, it has a kinetic and it has a potential here. As it go up, this kinetic will turn into the more potential energy. So, but the total energy will be constant. At point 1 and at point 2 and at point 3, all of these points, the total energy will be constant. Total energy is mechanical energy, which is potential plus kinetic. Just do this question. A basketball player make a free throw shot. The basketball leave the player hand at a speed of 7.6. The velocity here is given. The height is 2.21 above the floor. Determine the speed of the basketball as it go through the hoop, 3.05 above the floor. So you have this hoop here. Again, it is has a potential at this point, and now we want to find what is the velocity. So I'm just gonna move it here. So the point 1 here is point 1, and here is my point 2. So E kinetic at point 1 plus E potential at point 1 should be equal to E kinetic at point 2 plus E potential at point 2. Kinetic here is going to be half mv2, potential going to be mgh, as you see, put that mgy here. And here is half mv power 2 plus mgh for that. Just make sure you put for the second point. You know, we can cancel mass, divide each term by m. And I can multiply each term by 2. So 2 and 2 here cancel. Multiply by 2, multiply by 2, multiply by 2. So these 2 and 2 cancel. And this is what I have. Since I know I want to find the velocity 2 here, I need to just rearrange it for this velocity. Rearrange it for velocity 2, everything at the other side, take a square root. You have all of these numbers. Y1, Y2, G is 9.8 for initial velocity, and we solve for velocity 2. So since this is downward, this velocity is downward, but you can accept this is the magnitude of that velocity, 5.9. You can do question 3, 4, 5, 6, and 7. This is page 197. So other form of energy is thermal energy. Okay, when you have friction and this is moving, this object is moving from here to here, this is hockey puck is moving because of the friction, some of the energy will transfer into the heat and you will lost. So the work done by friction energy is W is force multiplied by displacement. Theta here is 180, that's why you have a negative there. Let's just look at this question. After leaving a player had a 19.9 kilogram curling rocks slides in a straight line for 28.8 meter, experiencing friction with a coefficient of kinetic friction 0.105. How much thermal energy is produced? So I just need to find a work done by that. Now, knowing that the thermal is the same as work done, force of friction multiplied by the displacement. Force of friction is the mu k multiplied by F of n. F of n is the normal force, which is equal to mg. We have mu, we have a mass, we have g is 9.8. Displacement we have, that would be the thermal energy. This is part B. Determine using conservation the walk speed as it left the player's hand. So since there is a final velocity will be 0, I want to find the initial velocity. the total displacement is 28.8. We need to come up with this. Energy of the kinetic should be the same as the thermal loss, because at the end it can turn into the zero, right? Engine kinetic energy here should be the same as the energy was lost during this motion. Now, since we got the thermal energy from previous step, kinetic energy half mv2, so we can rearrange for velocity here and find the velocity 7.7. So you can do question number 11, 12, 13, and 14.